Now let's see strict schedule. A schedule is strict if a value written by a transaction cannot be read or overwritten by other transactions until the transaction either commits or aborts. So the meaning of this one is, if you are going to have a transaction like this, now this transaction has to be committed, then only you are supposed to even write. See, it is more strict compared to the cascadeless. In cascadeless, what we did was, if you are going to have a read operation, then after this one commits, then only you are supposed to read. That is what you said. But there you didn't said anything about write. So according to the cascadeless, even this type of schedule will be allowed, which means now read A, write A, and now it is not yet committed, but then the other transaction can do write A and then commit, right? So this is actually cascadeless. So why? If it decides to undo the changes it did, it can do it without affecting anything by this one, right? So actually, when you are trying to read something without writing, it is a very rare case where you are going to write something without reading. This is called as blind write. Blind write means you are not reading it, you are directly writing it. That is, you are not seeing it, you are just writing it. That is why it is called as blind write. Okay. Now, by allowing this one, this schedule is going to be cascadeless. Now if you want to be even more strict, you don't want either read or write anything to happen until this one gets committed, right? That is what they are saying, read or overwritten. So here you are going to overwrite before it is committing, right? You are not going to allow this in strict. So for in strict, it is called as strict schedule because it is more stricter compared to the the cascadeless. Got it? So what can you say about the relation between strict and cascadeless? Every strict is definitely going to be cascadeless. Why? Here you are not allowing write or read, therefore write or read will appear only after the commit, and therefore there will be no need of rolling back this if this one rolls back. Therefore it is cascadeless, right? So now if you observe it, all the three, one is recoverable, other is cascadeless, and the other one is let's say strict. If you observe this, in case of recoverable, we are saying that the commit should be ordered. Let us say if this is T1 and if this is T2, now T2, if it reads anything from T1, that from T1, then T2 has to commit only after this, right? So this is the only restriction for recoverable schedules. Now coming to cascadeless schedules, it is saying that if T2 wants to read something from T1, then let T1 commit, then only you read. This is what cascadeless is saying, right? By putting this, what we are saying is, since this C will always be following this, the commit of this will always be following this, you can ensure that every cascadeless schedule is already recoverable, which means this condition is also embedded in this condition. Now if you look at this strict schedules, what is it trying to say is, it is not just about read. Whatever operation it is, read or write, you have to put only after this, which means if you have T1 and T2, and if T2 is trying to blind write something which T1 has written, it is saying that wait until it gets committed, then only you write or you read, then only you commit, right? Therefore it is even more stricter than this. Therefore if you observe this strict schedule, you are not allowing anyone to read until you commit this one. Therefore every strict schedule is definitely cascadeless. Now if you look at cascadeless, you are not allowing this read to happen before this, therefore you are not allowing this commit to happen before this commit. So every cascadeless is recoverable. Got it? So now if you have to see, it might be confusing, but if you slowly listen to this, it will be easy. Okay. Now if you put all these things together, right? So this is about recoverable, this is about cascadeless, and this is about strict. Now if you put all these points together, whatever I discussed till now, then you are going to observe this point. Now let's see this. Then you can clearly see that one is right. Now if you observe this, every strict schedule is going to be cascadeless schedule, and every cascadeless schedule is going to be recoverable schedule. That is the meaning of it. If we take a strict schedule, it is both cascadeless as well as recoverable. And if you take any cascadeless schedule, see what is this set? This is set of all strict schedules. If you look at set of all strict schedules, they are definitely cascadeless, and if you look at set of all cascadeless schedules, they are definitely recoverable, right? Now if you want to summarize all the information that we have seen till now, what is that we have seen till now is what is a schedule, right? Now a schedule is nothing but the way in which you are going to execute many transactions together. That is a schedule. How we are going to execute the operations of many transactions which are presented to you. Now I told you that a schedule can be of two types. One is serializable and the other one is non-serializable. Now if you look at the serializable schedule, you are going to completely perform one transaction, then only you are going to start the next one. In case if there is any reading, right, so you need not worry about it, because one transaction is going to get committed, then only you are going to start either read or write of other transaction. And so every serializable schedule is definitely strict. Are you getting this? Every serializable schedule is definitely strict. Why is it strict? Because you are going to start with a transaction, let's say T1, and you are going to complete it, commit it, then only you are going to start the next transaction T2, either read or write, I don't care, it is going to start only after this commit, right? Therefore it is definitely strict. Now as I told you that every strict schedule is definitely cascadeless as well as recoverable, right? So you can think of serializable schedule as if it is obeying all the properties. Got it? Now coming to non-serial schedules, so don't get confused here, it is very simple concept, right? So every serial schedule is strict, therefore it is going to be everything, right? Now coming to the non-serializable schedules, now some of them may be recoverable and some of them may not be recoverable, right? Some of them may be recoverable and some of them may be non-recoverable. So what do I mean by this? There might be some transactions which might get committed before the transaction from which it read has committed. In that case it is non-recoverable, right? And now coming to recoverable schedules, some of the non-serial schedules may be cascading and some of them may be cascadeless or some of them may be cascading. What does it mean? Whenever the schedule is recoverable, there might be sometimes a need for rollback and there might be sometimes no need for rollback, right? And now coming to this cascadeless schedule, some of them may be strict and some of them may be non-strict. Got it? So this is the classification for non-serial schedules, right? So in serial schedules directly they are strict, therefore they are everything. In non-serial schedules you are going to get this entire classification, right? So if you look at it in terms of this diagram, okay, now you can say that this is set of all non-serializable schedules. Got it? And this is how you can look at it. Now if you want to even put serializable schedules into this diagram, it is somewhat difficult to put it there, right? Why? You might have to put the serializable schedules inside this, but then that will say that every serializable schedule is non-serializable schedule, so let's not put it there. Got it? So what I mean to say is there might be some non-serializable schedules which are not recoverable. So what are the schedules that fall here? The schedules which are non-serializable and which are not recoverable, which means this part, right? If you consider that this outer part, this outer ring, then the outer ring is going to represent this one, right? And now what are the if you look at this entire ring, okay, between this one and this one, this part. If you look at this part, this is set of all recoverable schedules which are not cascading, which means these are recoverable but cascading. This is cascadeless. This is recoverable but cascading, which means this part. They are recoverable but cascading. Now if you look at this part, right, let us say this part. Now what is it? They are cascadeless but not strict. So which means they are cascadeless but not strict, this part. Now if you look at this one, it is strict, which means this part. Got it? Now if you union this one and this one, you are going to get cascadeless, which means if you union this part and this part, you are going to get all the cascadeless schedules. Got it? And if you union this one and this one, which means cascadeless and cascading, you are going to get all recoverable schedules, right? And if you union this one and this one, so which means recoverable schedules and non-recoverable schedules, you are going to get the total non-serial schedules. Got it? Which means this one and this one is going to give you this. Understood that? Okay.